This is Mr. Brooks, and welcome to Lesson 6.6, Placing Figures in the Coordinate Plane. In this lesson, we're going to name coordinates of special figures by using their properties, as you will see in Example 1. In Example 1, an art class is asked to create t-shirt designs by drawing quadrilaterals and connecting their midpoints to form other quadrilaterals. It says, Tiana claims that everyone's inner quadrilateral will be a parallelogram, and then ask, is she correct? Now, how in the world would we prove that if you draw any quadrilateral at all, and then connect the midpoints of that quadrilateral, that the interior figure will be a parallelogram? The way you're going to do this is we're going to use letters instead of numbers. And if we can get it to work for the variables, then it should work for any numbers that we plug in for those variables. The way we begin is by drawing quadrilateral OACE with one vertex O at the origin and one side along the x-axis. Next, we're going to find the midpoints of all four sides of our quadrilateral. How do you find the midpoints? Well, midpoint formula tells you to add up your x's, divide by 2, then add up your y's and divide by 2. Now first I would like to point out that the coordinates of our original quadrilateral, the red one, those are all multiples of 2. You can see the coordinates of A is the ordered pair 2A, 2B, and so on. First, let's find the midpoint of OE, the bottom part. U is the midpoint of OE. What are the coordinates of U going to be? Well, first you add up your x coordinates, divide by 2, then you add up your y coordinates, divide by 2. And as you can see, we get the ordered pair E0. And then let's get the midpoint of OA, which is called T. So you're going to add up your x coordinates, divide by 2, add up your y coordinates, divide by 2, and you get the ordered pair AB. When we do it for W, we get something a little more interesting. We end up getting the ordered pair A plus C, B plus D, and then for V, we get the ordered pair C plus E, D. Okay, so now we found all of our midpoints. Now how are we going to find out if the interior quadrilateral, the blue one, is a parallelogram, like Tiana suggested? Well, we have to figure out if both pair of opposite sides are parallel. So now we're going to use slope formula. I use slope formula on TW. Remember, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we do the slope of TW, and we get d over c. Then we do the slope of UV, and we get d over c as well. So this pair of sides ends up being parallel. Now in quick check number 1, they ask you to find the slope of the other two sides. So I want you to please pause the video while you try to get the slope of TU and the slope of WV and see if those are the same. Now I know they already did this for us in the book, but I want to do it one more time to make sure you understand how to find the midpoint. Let's find the coordinates of V, which is the midpoint of CE. So you're going to add up your x's, 2c plus 2e all over 2. And we're going to add up our y's, 2d plus 0 all over 2. Alright, now when we pull out a 2 on top and then divide by 2, you can see we get the coordinates of V to be the ordered pair C plus E, comma, D, which is what they had in the book. And they're asking us to get the slope of WV. Well, if you use the same midpoint formula on W, you're going to get the ordered pair A plus C, B plus D. A plus C, B plus D. All right, now, how are we going to get the slope of this line right here, WB? Well, now we use the slope formula. Slope formula. You're going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, here we go. So we're going to do B plus D minus the quantity of D over, now we'll do our x's. A plus C minus the quantity of C plus E. On top, we just get B. On the bottom, we distribute that negative. You're going to get A plus C minus C plus E. All right, and that reduces down to B over A plus E. Now getting the slope of segment TV should not be as hard because T has the coordinates AB and U has the coordinates E0. All right, so we're going to subtract our y's. So you get on top you get B minus 0 over, now we're going to subtract our x's, A minus E. And as you can see, that reduces to B over A minus E. Since both of these slopes are the same, slope of TV and the slope of W, excuse me, that was the slope of TU. And the slope of WV are the same, we should, whoops, I forgot to change this to a negative. That should be a negative. Now, since the slopes are the same, when I distributed my E, I should have changed the C and the E. Distribute the negative and the C and the E become negative. Anyway, now that the slopes are the same, you can see that those two lines are also parallel. So, Tiana was correct. No matter what figure you begin with, what quadrilateral you begin with, when you connect the midpoints, and then of all four sides, the interior figure is always going to be a parallelogram. Again, we prove this using what's called coordinate geometry. Instead of using numbers, we use letters. And now no matter what numbers you plug in there for those letters, it's always going to be true. Now again, on example 1 and quick check number 1, it worked better for us to put one vertex at the origin and one side of the figure along the x or y axis. As we're going to see in example 2, sometimes it works better to center the figure about the origin. In example 2, they center this figure at the origin and ask us the coordinates of K, N, and M. I would like to begin with M. M is straight down from L. So we know that the coordinates of M are going to be, first letter tells you left or right, second tells you up or down. So M is going to be the ordered pair A and then negative B. It's the same distance below the x-axis as L is above it. And it's the same distance to the right of the origin. So now let's try to get K. K is going to be a negative A. It's the same distance to the left of the origin as L is, and it's the same height as A. Excuse me, the same height as L. So K is going to be the order pair, negative B, A. N is going to have the same x coordinate as K, which is a negative A, and the same y coordinate as M, which is a negative B. All right, now let's take a look at quick check number 2. In quick check number 2, we have parallelogram OPQR, and we're asked to try to get the coordinates of Q. Please pause the video while you try to figure this out. Alright, if this thing is a parallelogram and OP is horizontal, it's right on the x-axis, then RQ is going to be horizontal. So right away we should know the y-coordinate of Q to be C. It's the same height as R. How high was R? C units high. So how high is Q going to be? C units high. Now we need to figure out the x-coordinate of Q. To get the x-coordinate of Q, I'm going to form a right triangle with R, and hopefully everybody would agree that this distance right here is B units. R is B units to the right, C units up. So when I bring this straight down, which should give me the x-coordinate of this distance, is also going to be B units, because those two triangles are congruent. Well, if that's B units and this distance is S units, then the x-coordinate of Q is simply B plus S, comma, C. Right there is your coordinates of Q. This is the answer to quick trick number 2, and this concludes lesson 6.6 and chapter 6.